Okay, these are the trig equations and evaluations from lesson 55, and on these I'm going to do this without using the unit circle. I'm going to do it using the triangles that we learned about at the beginning of the year because I don't know if some of you like to do it that way better. The two triangles we dealt with came from when you have a square with side 1 and you split that square into two right triangles. You end up with a 45, 45, 90 triangle. And if the sides are 1, then when you use the Pythagorean theorem to find the diagonal, it turns out that the diagonal is equal to the square root of 2. So 1, 1, square root of 2 is the ratio you get in a 45, 45, 90 triangle, and therefore you can find the sine, cosine, tangent of 45 degrees. Sine is opposite over hypotenuse, so sine 45 is 1 over the square root of 2, which is square root of 2 over 2 if you rationalize it. And then cosine 45, again, opposite over hypotenuse, so it's opposite over square root of 2. So, I'm sorry, adjacent over hypotenuse, so adjacent over square root of 2, 1 over square root of 2. So that's still square root of 2 over 2. So in the 45, 45, 90 triangle, sine and cosine have the same value, but it depends on what quadrant you're in as far as what their signs are going to be. Then tangent of a 45 degree angle is always either 1 or negative 1, depending on what quadrant you're in, because you're just taking opposite over adjacent. So that's 1 over 1, or 1. So for all the different angles that relate to 45, like 135, 225, 315, all those angles are going to have some variation of either square root of 2 over 2 or negative square root of 2 over 2 for the sine and cosine, and either 1 or negative 1 for the tangent. Alright, so in this problem, and then we also talked about the 30, 60, 90 triangle, which is what happens if you have an equilateral triangle of side 2, and you split it down the middle to create two triangles. Then what you end up with is a 30, 60, 90 triangle, and we know that the altitude of an equilateral triangle just splits it in half, so this is 1, and then you have 1 for this leg, the short leg that's across from the 30 degree angle. You have 2 for your hypotenuse because we just said it's an equilateral triangle with side 2, and then if you wanted to find this height, the long leg of that triangle, you would use the Pythagorean theorem, and you would say 1 squared plus x squared equals 2 squared. So 1 plus x squared equals 4, x squared equals 4 minus 1, which is 3, and x is the square root of 3. So when you have a 30, 60, 90 triangle, the ratio is 1 to 2 to the square root of 3, where 1 is across from the 30 degree angle, square root of 3 is across from the 60 degree angle, and 2 is the hypotenuse. So that's where these triangles came from, and they are what we use to create the unit circle, which would show us all the values for all 30, 60, and 45 degree angles in the different quadrants. Okay, so in this problem, I'm looking at 3 tangent theta minus square root of 3 equals 0. So the first thing I'm going to do is isolate the trig function by adding square root of 3 on both sides. And then I've got to divide by 3 to get tangent all by itself. So this is square root of 3 over 3, which if you didn't rationalize it would be 1 over the square root of 3. And this helps a little bit to figure out which triangle, which angles have that tangent. So you know it's not going to be the 45 degree angle because that's always going to have a tangent of 1 or negative 1. So you're going to be in this triangle here, and you're looking for when the tangent is 1 over the square root of 3. So opposite over adjacent is, if you go across from a 30 degree angle, opposite over adjacent is 1 over the square root of 3, or square root of 3 over 3. So you know that you're looking at a 30 degree angle here. Theta must be 30. Okay, but if we look at the quadrants, theta is also has a positive value over here in the third quadrant. So theta is positive here in the first quadrant, and that would be at 30 degrees you'd have this tangent. But then it's also true for the 30 degree angle over here in the third quadrant, because x and y are both negative, and so therefore tangent is positive. So this 30 degree angle over here in the third quadrant is just 180 degrees plus another 30, which puts you at 210. So theta could be 30 or it could be 210. So those are the places where tangent theta is 1 over the square root of 3 or square root of 3 over 3. And it just comes from knowing where tangent is positive in the first or the third quadrant, and then knowing this triangle, this 30, 60, 90 triangle, knowing those ratios that go with it. So if you didn't use the unit circle, you can still find these values just by using these two triangles that we learned about at the beginning of the year. So here we have on number 13, we have tangent 3 theta equals square root of 3 over 3. So this time it's the same situation as up here, same triangle, same situation, but now 3 theta is going to be 30, or 3 theta is going to be 210. Alright, so in this case we have to solve for theta, and we just divide both sides by 3, so theta is 10 or theta is 70. Alright, when you have a argument that is multiplied, there's a coefficient on theta of something greater than 1, then you are going to have more answers than you would normally have, because we're saying theta can go from 0 to 360, so 3 theta can go from 0 to 3 times 360. Alright, so instead of adding 360 to this 30-degree angle and then dividing it by 3 to get theta, we'll just divide 360 by 3 and add that to our theta. So I can add another 120 degrees to this and get 130, and that's another possibility, because if I spin around to 130 for theta, 3 times 130 is 390, which puts me in the first quadrant at 30 degrees, which is where you get a tangent of square root of 3 over 3. So I can spin around. I can spin around again and add another 120, and I will end up with 250 for theta, and that makes 3 theta 750, which is also going to give you square root of 3 over 3, because you're right back in the first quadrant at that 30-degree angle. If I spin around again, it would be 370, and that's too much because I want to stay between 0 and 360. I can add 120 to the 70 2 times also, so 70 plus 120 is 190, and then 190 plus 120 is 210. Is that right? It's 310, sorry. So yeah, so all these answers work for that problem, because you're just spinning around right back to those same two angles we talked about. Okay, cosecant 2 theta minus 1 equals 0. First thing we want to do is add 1 on both sides to isolate the trig function. So cosecant 2 theta is 1. Cosecant is 1 over sine. So we're looking at when sine is 1 over 1, so it's going to be 1. And sine is only 1 right here at 90 degrees. That's the only place that sine is 1, because the y coordinate is 1 here. So this, the cosecant is 1 over 1 at 90 degrees. So 2 theta is going to be 90, which means that theta would be 45. Normally, if this was just theta for the argument, I'd be done, because that's the only place you're going to get a positive 1 for your y value. But since I have, this is really what cosecant of 2 theta, I can add another possibility by just dividing 360 by 2 and get 180 and add that to my theta. So 45 plus 180 is 225. So that's another possibility, because if you say cosecant of 2 times 225, that puts you at 450, which is 360 plus 90. So you're just right back at the same place. It's just that you spun around the circle to that same place where that happens again. But the only reason you could do that is because we're not taking the cosecant of theta, we're taking the cosecant of 2 theta. And theta can go between 0 and 360. 2 theta can go between 0 and 720, so I can spin around an extra time. Okay, number 17, you've got some trig functions that you just want to evaluate at certain places. So we're at negative 3 pi over 4, and negative 3 pi over 4 is here at a 45-degree angle. It's negative, there's negative pi over 4, negative 2 pi over 4, negative 3 pi over 4. Alright, so this is a 45, 45, 90, which is 1, 1, square root of 2. And we are looking at the secant. The secant is 1 over cosine. remember. So the cosine here at 45 degrees is adjacent over hypotenuse, so it's 1 over the square root of 2, but it's negative because we're in the third quadrant, so this is negative, negative. So the secant is going to be the reciprocal of 1 over square root of 2, so it's going to just be square root of 2. Like I said, it's negative because we're in the third quadrant, and then we're going to square that. All right, cotangent 7 pi over 6. 7 pi over 6, remember 7/6 is 1 and 1/6, so if we're taking 7 pi over 6, that's 1 pi, so that's over here, and 1 more pi over 6, which is 30. So this is a 30-degree angle, and we're taking the cotangent. So cotangent, okay, we're dealing with a 30, 60, 90 triangle. So let's just remember what those ratios are. That's 1, 2, square root of 3. So cotangent is, tangent is 1 over square root of 3 because it's opposite over adjacent. So cotangent is going to be square root of 3 over 1, so it'll be square root of 3. And this is we're in the third quadrant where cotangent or tangent, they're both positive. So it's going to be a positive square root of 3, and we're supposed to square it. Right here, we're at tangent squared 7 pi over 6. It's going to be, you're here at 0 degrees. You're going to go, again, 1 and 1/6 pi, but this time you're going to go in the clockwise direction. So you're going to go all the way around pi, and then 1 more pi over 6, which is, again, a 30, 60, 90 triangle right here. And tangent in the second quadrant is negative because this side is negative and this side is positive. So opposite over adjacent is going to be a positive over a negative, which makes it negative. So this thing here, this tangent is going to be negative, and since it's a 30-degree angle, we are saying opposite over adjacent, so 1 over the square root of 3, or square root of 3 over 3, however you want to do it. And we're supposed to multiply that by 2, and we're supposed to square it. So negative square root of 2 squared is just 2. Square root of 3 squared is 3. And then 2 times 1/3. So 2 minus 3 is negative 1, and then, plus 2/3 is going to be negative 1/3. All right, number 18, again, we're evaluating some trig functions. So we are saying that f of x is secant squared x and g of x is cosecant squared x. We're going to find f of 3 pi over 4. So f of 3 pi over 4, you just plug in for x, whatever's in these parentheses. So secant squared 3 pi over 4. And then we are going to subtract g at negative 4 pi over 3. So that is going to be cosecant squared negative 4 pi over 3. So we have to find out where we are. 3 pi over 4, that means you're going pi over 4, 2 pi over 4, 3 pi over 4. Puts you in the middle of the second quadrant, and you're at a 45-degree angle. So this is a 45, 45, 90 triangle, and it is 1, 1, square root of 2. The x-coordinate is negative, so that is, you can put a negative sign there. And secant squared, secant is 1 over cosine. So cosine of 45 is negative 1 over the square root of 2, adjacent over hypotenuse, negative 1 over the square root of 2. So if I flip that, I'm going to get negative square root of 2 because secant is the reciprocal of cosine. So negative 1 over square root of 2, flip it, you get negative square root of 2, and then you're supposed to square it. All right, cosecant squared negative 4 pi over 3. Now you're going to start here at 0, 4 pi over 3. If you have 4/3, that's 1 and 1/3. So 4 pi over 3 is 1 and 1/3 pi. So you're starting at 0, you're going in the negative direction, so you're going clockwise. You go a whole pi, that's halfway around the circle, and then another 1/3 pi, which is a 60-degree angle. So now you're dealing with a 30, 60, 90 triangle. So this is 30, 60, 90. So 1, 2, square root of 3. And we are in the second quadrant. Cosecant, remember, is 1 over sine. And in the second quadrant, sine is positive. At y, the y coordinate is positive. So it's going to be a positive answer. and we're going to square it. And if we look at the triangle, we're talking about a 60-degree angle. Sine is opposite over hypotenuse, so square root of 3 over 2 is what we have here. So square that and you get 2 minus 3/4 equals 8/4 minus 3/4 is 5/4. Okay, now we want to take the tangent of the angle whose cosine is -4/5. So the angle whose cosine is -4/5, cosine is negative in the second quadrant. So it's going to be this triangle here. The cosine of the angle, theta, is adjacent over hypotenuse. So the x-coordinate is negative in this quadrant. You go left. Alright, so we're in that quadrant. We want to find out what this leg is. This leg, the 3, 4, 5 right triangle is a well-known triangle. You don't necessarily have to figure this out, but you could use the Pythagorean theorem to figure out what that is. Y, I'll call it. So you'd say -4 squared plus y squared equals 5 squared, so that's 16 plus y squared equals 25, so y squared equals 9, so y is 3. So this side turns out to be 3, and so this is the triangle we're talking about. And so we're trying to find the tangent of this angle theta here. So tangent is an opposite over adjacent, so it's 3 over -4. So the answer is 3 over 4, but it's negative because we're in the second quadrant. And so this is an opposite over adjacent is going to be negative. So that would be your answer for that. Alright, now we're looking for the cosine of the angle whose sine is -3/4. The angle whose sine is -3/4 is in the fourth quadrant, because that's where sine is negative. The range for arcsine is -90 to 90. You gotta remember that. So this is where angles have negative values for their sine. Alright, so the angle theta has a sine of -3/4, so that is opposite over hypotenuse. And so then this is another, well, it's not a 3, 4, 5 triangle because the hypotenuse is 4, so we have to use the Pythagorean theorem to find out value for x. So x squared plus -3 squared is 4 squared, so x squared plus 9 is 16. X squared is 16 minus 9 is 7, so x is the square root of 7. So that's our triangle, and we want the cosine of this angle, so that is square root of 7 adjacent over hypotenuse, so square root of 7 over 4.